Hello student, this the video is about the interfacing of strain gauge with the ATmega328p. In the previous video lecture, I discussed about the interfacing of interfacing of temperature sensor and LVDT with the ATmega328p. This topic is from the unit 6 of our the EEE subject. The strain gauge is also a sensor. It is the actually resistive sensor whose the resistance varies when we apply the force. That means when we apply any force, that time there will be the change in the resistance of the strain gauge materials. This the strain gauge converts force, pressure, tension, weight, etc. into a change in electrical resistance, which can then be measured. The working principle of the strain gauge is when an external force is applied on an object due to which there is a deformation occur in the shape of the object. This the deformation in the shape either compressive or tensile, that is called as the strain, and it is measured by the strain gauge. This is the diagram for the strain gauge. This is the foil type of the strain gauge. Now see here, when we apply any force or the pressure or the weight on the strain gauge material, that time due to that the applied pressure or the weight, there will be the change in its the resistance, and so that the strain gauge material is always connected as a one arm of the Wheatstone bridge circuitry, in which the other arms resistance, that means the R1, R2 and R3 values are the same. Only there will be the change in the resistance of the strain gauge material due to change in the applied pressure. So that when we applied any pressure, due to that there will be the change in the resistance of the strain gauge, and due to that the change in the resistance of the strain gauge, the Wheatstone bridge circuitry becomes the unbalanced, and so that we get the change in the voltage that we will measure. So that we measure here the change in the resistance. This is the actual working of the strain gauge. There are the different types of the strain gauge. Basically, two types, wire gauge and the foil type. Semiconductor gauge. A wire gauge has the again different types, that means the unbonded, bonded and foil type. In this the wire is used, and in the semiconductor strain gauge, the semiconductor material such as the silicon, germanium can be used for the strain gauge. In this the type of the strain gauge is the foil type of the strain gauge. Then where we can use the strain gauge. The strain gauge we can use in the field of the mechanical engineering development, as well as it is used to measure the stress generated by the different machineries. As well as the strain gauge can be used in the field of component testing of the aircraft, like linkages, structural damage, etc. It is also used to measure the torque applied by a motor, turbine or the engine to fans, generator, wheels or the propellers. The equipment is found in the power plants, ships, automobiles, industries at a large. The strain gauge we can also use for the load cell measurement, or we can say simply the weight measurement. It is often used in the weight machines, electronics such as the electronic weight machines. This is the interfacing diagram of the strain gauge with the ATmega328p. As I told in the working of the strain gauge, that the strain gauge is always connected in the Wheatstone bridge circuit. So that this is the load cell or the strain gauge in the Wheatstone bridge. The output of the strain load cell or the Wheatstone bridge is given as an input to the instrumentation amplifier. Then the output, that means the amplified output, we applied to the ATmega328p through the H0 pin of the ATmega328p. H0 pin reads the output of the strain gauge. Then this is the crystal oscillatory circuit, and whatever the change in the output, or that the weight measure, that or the output of the strain gauge, we can display on the LCD display, so that here the LCD display is also interfaced through the 8, 9, 10, 11, 12, 13 pins. 3, 5, 21 pin is connected to ground, 4 and 6 pin is connected to VCC. So this is the interfacing of this strain gauge with the ATmega328p. Algorithm. Obviously we have to start first, then we have to include the liquid crystal library file, then configure the H0 pin as an analog input to read the strain gauge sensor output. Then we have to declare variables for strain gauge for storing the strain values. Then read the strain sensor values, and then display that the strain sensor values on the LCD and the end. So student, this is about the interfacing of the strain gauge with the ATmega328p. Thank you.